G'day YouTube, Choby from Oz here. So today I'm wiring up the forward and reverse switch on the AL960B lathe, and what I'm planning to reuse is this component, which is a rotary switch with a off, forward and reverse position so that I can control the VFD. Now the VFD has an input function which, let me see if I can bring that up. The VFD has an input function whereby if I supply a ground to input D11, that will be treated as spin the motor forward, and if I supply a ground to input D12, that will be seen as reverse. So my goal here is to, using this switch, which was previously I'm imagining a single phase motor, a reversible motor, electrical lettering, fairly common sort of standards. Not being an electrician, I don't know what the M6, the M5, the UV, S and R actually mean, but I have surmised it based on my electrickery. So this is the rotary encoder. If we have a bit of a look down in the guts, you'll see next to this blue wire there's a little piece of metal. Perhaps I should have shown a picture of this before I put it back together again, but essentially that's a bridge. There's another one up there between those two terminals. You can just sort of see it in there, and that's part of how the reversing function of this switch works. I dived in deep, mapped out the functions in the reverse, off and forward positions, and what I've found is that there's actually a set of 12 screws. 6 of those are labelled 5VRSUV, U6, and in the off position, R is connected across these middle pair, S is connected across these middle pair, and the central pair is not connected at all. The dotted lines indicate where I've pulled those bridges out from. In the reverse position, the switch connects R to U and V to this side of the S. It also connects these middle pair and this middle pair, which, if you don't have those bridges in, don't achieve anything. Forward position, we have 5 connected to one side of this central bridge, R connected to U, V connected to one side of the central bridge, S is to that side is the existing hardware bridge, and S through to 6. So by showing where the dotted lines appear, in the forward position they don't achieve anything for us. In the off position they don't achieve anything for us. However, in the reverse position it has the function of connecting 5 through that bridge to this VS pair, 6 through this bridge to the RU pair. So we have RU and VS connected in both cases. What we have is 5 and 6 being connected to a different pair in forward and in reverse. So in forward, 5 connects to R and U, 6 connects to V and S. In reverse, 5 connects to V and S, 6 connects to R and U. So essentially I've figured out, based on this, with this wiring, that this is what this mess of cables at the end is going to give me. In order for my forward function to work, if I have ground connected to 5 and R connected to the forward input, if I move in the forward direction, 5 will connect to R, I will go forward. In my reverse direction, if I have V connected to the reverse input and 5 connected to ground, I'll have 5 connected to V, and then the machine will turn in reverse. Whenever I'm in neutral, in the central position, 5 and 6 have no connection. So, I'm not going to use the 6 lead. In this instance, V, S, R, U are unconnected. So, 6 connected to V, which is an input of the device, will not actually ground, it'll just float. 5 connected to V, 6 connected to R will not actually do anything with R, it won't ground it, it'll just float it. So that should allow us to maintain that. There is a possibility, if it doesn't work, that what we actually want is those to be held high when we go to a different function. So potentially, if we wanted 5 low when we're forward, so if we use the R as the input for forward, we want it low here. If we wanted to pull it high, we could essentially add the 10 volt positive feed to 6, which would pull R high. 5 to V, V would be pulled low, and if 6 was high, V would be pulled high. So if we end up with a bit of a floating system or don't have a positive output, we certainly can pull those pins high when they're not in use and pull them low when we want that function to operate. Interested in your thoughts, whether they should be pulled high or whether there be internal pull-up resistors on the inputs. Typically I'd expect a pull-up resistor would be on the input. What does a pull-up resistor do? So if we've got plus 10 volts through a resistor to our input, now with the long lead that we have to the switch gear, it's essentially about 2 feet long. You essentially have a long fly lead. Now that can act like an antenna, where we have 10 volts through a resistor to an input. That will tend to pull this input up to 10 volts if there's no other value on this loose wire. When we attach our signal ground to here, what we end up with is our input pulled low and the resistor is a sufficiently high value so that we don't have a dead short. So this is normally what you would see on an input, is a pull-up resistor or potentially an enableable pull-up resistor in software, so that your inputs are held high until they are grounded by that external input. I'm going to go with those internal pull-ups and just use the ground on the pin 5 with our V and R inputs and leave our other pair of wires unconnected. Fun times. So now that this is all put back together, we're ready to finalise the box and make ready to put it on the lathe. It's being decidedly noisy this morning. And there we have our finished switch, ready to go into the lathe. Okay, so that's the switch now in place on the lathe. Through to the actuator lever. I haven't yet got the end support. There's a little bit of play in these two screws so they can be aligned accordingly. Essentially we've got reverse and forward, which you can see being transferred to the switch there. Okay, we're just going to test our wiring based on our expectation. So we're currently in our off position, so I'm expecting no connection to 5, no connection between the U, the V, the R and the S. Okay, going to switch to forward, and so now I'm expecting 5, and U to be connected, and 5 and R to be connected, but not V, S or M6, and I'm expecting 6 to be connected to S and V. So that's our forward direction. Our reverse direction, I'm expecting 6 not connected to S and V, but connected to R and U. 5 I'm connected to V and S. So the switch is operating as expected. Our 5 lead is joined up to the brown and the red wires. Our U and R pair is connected to the yellow, and our V and S pair is connected to orange. Next up is the wiring down deep inside of the VFD. So we've got a ground wire, and according to our wiring here, our forward default should be D11, our reverse should be D12, DI1, DI2, sorry, and ground. So now we just need to wire up those. Bring it back. 5, U and V. And in the box, got ground connected to 5, D1 connected to U, and D2 connected to... Alright, so we're showing 11 Hertz. Let's drop that down to 5 Hertz. Got our wiring connected through the switch. I'll put us into low 2 and forward. Reverse. Okay. So that tells me I need to figure out the control to allow it to take the remote digital input. Alright, B0 parameter 2 needs to be 1 in order to be triggered from remote. So we're now seeing a remote signal, which, standing back, contact, check that out, and reverse. You saw it here first, people. VFD control. Let's ramp up our frequency a little bit. So this is full speed in lowest gear. What happens? Okay, so that means our speed control is running at 6 Hertz. We have terminal mode operation, terminal mode operation, but no input on our potentiometer. So in order to have a speed control with this same terminal block, I'll need to wire a feed through on that. Interesting.